So hello viewers, today we will be synthesizing hexamethylene tetramine, also known as hexamine. Hexamine has wide range of applications. Its urotrophins are used to treat urinary tract infections and it's also used as emergency fire starters in camping. Hexamine is also one of the major primary component of making C4 explosive, aka the RDX. So before getting started, let's have a look at the reaction mechanism. In this reaction, we will be using 40% formaldehyde and 30% ammonia. The net reaction of this mechanism is that 3 ammonia molecules combines with 6 formaldehyde molecules to give 1 molecule of hexamine and 6H2O. Although the water is one of the major product of this reaction, the solutions we are using that here at ammonia and formaldehyde are gases, and the gases of the solutions have been utilized here, so that the major product of this reaction is going to be water. Although this may look like a single step reaction, but this reaction mechanism has dozens of intermediates, and throughout my research in this substance what I understood is that no one really understands the reaction mechanism. It is a series of reactions taking place, and the ammonia molecules and the formaldehyde molecules get stacked onto each other, and at the end the hexamine is formed. So before getting started, formaldehyde is carcinogenic and ammonia can literally burn down your lungs if you inhale some of it. So what do I recommend doing here is better work under a fume hood or an open space where there is no need for you to breathing in those fumes. So let's get started. To a 500 ml beaker, there is no exact quantities for these chemicals to be mixed. What I learned that the concentration of ammonia must be greater than that of formaldehyde. And another thing to say is that this reaction is really exothermic, and it produces a lot of heat. In small scale it doesn't really matter, but when you are working under large scale it's really dangerous and it produces a lot of heat. So to have a look at the temperature, we will be placing a thermometer right here. So right now it's around 25 degrees Celsius, which is pretty commonly room temperature here in India. So what I'm gonna do is that I'm gonna slowly pour in this ammonia while constantly stirring the mixture. We don't want this thing to really, we don't want the temperature levels to be really high. We have to maintain the temperature, we have to maintain it at particular temperature so that it won't cause any trouble. So what I'm doing right here is that I'm slowly mixing in ammonia. Leave it. Yeah, I think it's pretty difficult to see those fumes in this video, but there is a lot of heat has been producing here, as this is an exothermic reaction. So let's have a look at the temperature right now. Yeah, this reaction is now, this mixture is at 62 degrees Celsius. We started at 25 and it has reached 62. So let's wait for some time until all those ammonia and formaldehyde is reacted and the temperature is reduced. Let's remove the thermometer and give this mixture a quick stir, so that all the ammonia and formaldehyde has been reacted. So, and major product of this reaction right here is water. Actually 6 molecules of water has been liberated out. So what we're going to do is that we will be boiling this mixture until the concentration of this reaches down, until the water evaporates out, and hopefully we can find some crystallization taking place, and we will be transferring this to an heat source where the rest of the water can be evaporated, and hopefully we can get some pure hexamine. What do I recommend doing this is that if you're making something in large scale, it is perfectly alright to do it in a saucepan or something like a what to say an utensil made of metal, because ammonia and formaldehyde are which does not react with metals, and I am sure that it can be done with metals, but in our case we are not doing that in that case for synthesizing secondary explosives. So let's have a look at the temperature right now. Yeah, what do I see is that the ammonia is still reacting and the temperature is around 64 degrees Celsius. So let's leave this around for some time until the temperature reduces. Yeah, now the mixture of ammonia and formaldehyde has pretty much been reacted and now it's at room temperature. What we are going to do is that we will be boiling out the water. So to be sad, we don't have access to a hot plate stirrer or a heating mantle, so that we will be using a gas stove cooktop. And this one right here is a pressure cooker which I filled with some sand to maybe balance out the beaker. I do not recommend you trying this at home because it's really risky, but I've got used to it. Like I have done this thing like many times, so that I have confidence that I can do this. So we will be transferring this beaker inside this cooker so that we can hopefully see the water boiling out and the crystallization taking place. One thing to notice is that when you see the water boiling out and when the concentration is reduced, the hexamine will be coated. When you dip your glass rod into this mixture and have a look at it, you can see that the hexamine has been precipitated on the surface of the glass rod. It means that the most of the water which was produced as a byproduct in this reaction has been like vaporized, and it's time to switch off the heating and place it in room temperature. Right now it's raining in a country, so that we will be transferring and we will be keeping it under an heating element until all the water is evaporated, and hopefully we can get some pure hexamine. So let's turn off the heating and let's wait until this concentration reduces, and I'll show how the crystallization is starting to take place. Yeah, right now if you see that, you can see some white spots on the surface of the glass rod. This shows that the hexamine has been precipitated and it's dried out, you can see. So what I want you to do right now is that lower the heating and wait until almost all the water is boiled out, and you can see a bit of crystallization starting to take place. At that time, turn off the heating and transfer this beaker under a dehydrator or an oven, and bake this until all the water has been evaporated and until you get some solid crystals. So I don't have a dehydrator actually, but I made one. So after all the water has been dried out, we can test it.